Hey everyone, welcome back. Today on calculus class, I thought we'd look at some questions from Reddit. So we have this one here. There are 4 of them that we're going to look at, but this first one is if e to the xy minus y squared equals e minus 4, and then x equals 1/2 and y equals 2, then what is dy dx? We want to treat this like the derivative of the left is equal to the derivative of the right. Now, taking a look at the left and the right, I look at the right side, and I see that that's constant. E minus 4 is just a number. I mean, e is about 2.7. 2.7 minus 4, I think that's negative 1.3. So the derivative of just any plain old constant is just 0. Okay, so the left side then, we're going to take a look at each one of those separately. First, we're going to consider the derivative of e to the xy. If I consider xy as the power of e, then really what I'm looking at is the derivative with respect to x of e to the u, which is e to the u multiplied by du dx, which is e to the xy multiplied by the derivative of xy, knowing that xy was my u. X times y is a product, so the derivative of a product is the derivative of the first factor, x, multiplied by the second factor, so 1 times y, plus the first factor, x, multiplied by the derivative of the second factor, y, so x multiplied by dy dx. So now I have the derivative of e to the xy. For the second part of the left side, we've got the derivative of y squared, and the derivative of anything to the second power is 2 times that thing multiplied by the derivative of that thing. Okay, so after derivatives, I have that e to the xy power multiplied by the quantity of y plus xy prime minus 2y prime is equal to 0. And what I find is helpful from here is to substitute all of my values now. So let's substitute 1/2 for x and 2 for y. So that gives me e to the 1/2 times 2 multiplied by 2 plus xy prime, 1/2 times y prime minus 2 times 2 times y prime. Do all the multiplication first. I notice that y prime appears on the left side twice, so I'm going to group those together. But first I have to distribute that e. Let's move the 2e over to the right side. Factor out the y prime on the left side. Actually, no, let's multiply the left and right side by negative 2. Then we're going to factor on the left side, factor out that y prime. And then finally, we'll divide both sides by 8 minus e. So that gets me to 4e over 8 minus e. The next problem we have here is to find the second derivative if I know that y squared is equal to 10x. So we'll take the derivative of the left and the right. Luckily, we took the derivative of y squared in the previous problem, and then the derivative of 10x is actually pretty easy. And that gives me that 2y multiplied by y prime is equal to 10, which is the same thing as y times y prime equals 5. So y prime equals 5 over y, or 5y to the negative 1 power. Take the derivative of the left and the right side again, so the derivative of y prime is equal to the derivative of 5y to the negative 1 power. Y double prime is equal to 5 times negative 1, y to the negative 2 power, multiplied by y prime. So remember, the derivative of anything to the negative 1 power is equal to negative 1 multiplied by that thing to the decreased power, so negative 2, multiplied by that thing to the x power, so u to the negative 1, du dx. It just happens that we're taking the derivative of y. So let's clean up the second derivative. We get negative 5 multiplied by 1 over y squared multiplied by y prime. That gives us negative 5y prime over y squared. Remember from before, we said that y prime was equal to 5 over y. And from the beginning of the problem, we knew that y squared was 10x. And when you simplify that, you'll get negative 5 over 2xy. Now the third problem from Reddit asks, for what values of x does y squared minus 2x cubed minus 12x squared equal to 0 have horizontal tangent lines? Which, translating from calculus, mean when is dy dx equal to 0? So we'll take the derivative of the left and the right, simplify, and then we use our secret weapon. Dy dx is equal to 0 if there's going to be a horizontal tangent line. Substitute the 0, and we get a pretty simple second degree equation in x, which factors to negative 6 multiplied by the quantity of x plus 4 equaling 0, which gives me two solutions. X needs to be either equal to 0 or x needs to be equal to negative 4. For our last problem, we're going to find the second derivative for the function x squared minus y squared equals 8x plus 4y. The first thing I want to do is take the derivative of the left and make that equal to the derivative of the right. Now the derivative of x squared is 2x. The derivative of 2y is 2y multiplied by y prime. That's going to be equal to the derivative of 8x, which is just 8, plus the derivative of 4y, which is 4y prime. To make things manageable, we'll divide everything by 2, and then we'll take the derivative of the left again, and that'll be equal to the derivative of the right again. The derivative of x is 1 minus the derivative of y prime, which is a product. So I'm going to have to use the product rule on this one. The derivative of y prime is the derivative of y multiplied by y prime plus y multiplied by the derivative of y prime. That got a little bit squished in there, sorry about that. But that's going to be equal to the derivative of the right side, which is, well, the derivative of 4 is 0, plus the derivative of 2y prime, which is just 2y double prime. Let's clean that up just a little bit. So that's going to get me 1 minus y prime squared minus y double prime, and that's equal to 2y double prime. So y minus y prime squared is going to be equal to 2y double prime plus y double prime. Now on the right side, we're going to factor the y double prime, and that's going to be 2 plus y multiplied by y double prime. Now I notice on what I have right now, this very last line, I notice that there is a y prime. And most of the time when we do these questions, we don't want the second derivative in terms of y prime. So we'll need to find an equation that has y prime and use that to substitute. And that's this equation right here. I notice that this equation has y primes in it. So I'm going to use this equation. I'm going to solve for y prime. First, I'm going to subtract that 4 from the right side and add the y prime from the left. Factor the y prime on the right side, and then divide by 2 plus y. And now I have an equation for y prime in terms of only x and y, which I'm going to use to substitute. Back to the main problem, this simplifies or substitutes into 1 minus a quantity of x plus x minus 4 squared over 2 plus y equals 2 plus y multiplied by y double prime. And it'll be easier for me if I think of that second part of the left side as x minus 4 squared over 2 plus y squared. Now division is going to be a little bit easier if I move this over to a common denominator. So let's move the left side into a common denominator, which is just 2 plus y squared. So 1 is the same thing as 2 plus y squared over 2 plus y squared, which is the same thing as 2 plus y squared minus x minus 4 squared over 2 plus y squared. And now the last thing to do is divide by 2 plus y. And that's going to be equal to y double prime equals the quantity of 2 plus y squared minus the quantity of x minus 4 squared over the quantity of 2 plus y cubed. And that does it for all of these questions from Reddit. I have a whole series of calculus videos if you would like to check them out. And I will see you next time when we look at more calculus homework help. Have a good day.